This method consists in measuring several angles successively and finally closing the horizontal at the starting point. The final reading of the vernier A should be same, that is as its initial reading. As initial reading was 0, so when we complete one circle, the same, that is 0 reading must be there. So, if not, discrepancy is equally distributed among all the measured angles. Here there are 4 angles. So, the discrepancy is divided into the 4 number of angles equally. Procedure, what is the procedure? Suppose it is required to measure the angles AOB, BOC, COD. Then to measure these angles by rapid reiteration method, first step is set up the instrument over the station point O and level it accurately. So, it is being shown on your meter screen. Set the instrument at point O. So, direct the telescope towards point A first, which is known as referring object. Bisect it accurately and check the reading of the vernier as 0 or 360 degree. Loosen the lower clip for left hand side object and turn the telescope clockwise to the sight point B exactly. Reading the vernier against and the mean reading will give the value of angle AOB, that is we have measured now angle AOB. Similarly, we can measure angle BOC, BOD, DOC and COE. That completes one complete revolution. So, the reading at A should be as it was just at the start of the work, that is 0 degree. Finally, close the horizontal by sighting toward the referring point A. The vernier A should now read 360 degree. If not, note down the error, and this error occurred due to slip of the instrument, and if the error is small, it is equally distributed among the several angles, and if this error is large, the reading should be discarded. That is, now we have to take the reading again. If error is small, we can distribute the error, and if the error is more, we can discard the readings. So, now it was just all about horizontal angle. So, how we take the vertical angle? So, with the transit vernier theodolite, we can also measure vertical angle. So, what is vertical angle? As you can see on your meter screen, there are 3 sketches, various types of sketches. A vertical angle is an angle between the inclined line of sight. This is the advantage of the theodolite, that is you can move the telescope of the theodolite, that is you can transit the telescope of the theodolite up and down to any angle. So, the vertical angle is an angle between the inclined line of sight and horizontal. It may be an angle of elevation, that is when it is the point is above the horizontal line of sight, then it is angle of elevation, or a depression when the point is below the horizontal line of sight, accordingly as the object is above or below the horizontal plane. So, when you please see on your meter screen, there are 3 types of sketches in which angle of elevations and angle of depressions are shown. So, when we measure the vertical angle, we can measure both of the angles, either it is angle of elevation or angle of depression also. So, what is the procedure for measuring this angle? Set up the theodolite at station point O and level it accurately with reference to the altitude bubble. Set the 0 of the vertical vernier exactly to the 0 of the vertical circle, clamp and tangent screw. Bring the bubble of the altitude level in the central position by using clip screw. That is, we are to level the upper altitude bubble tube with the help of a clip screw. The line of sight is thus made horizontal and vernier still reads 0. So, loosen the vertical circle, clamp screw and direct the telescope towards point A and sight it exactly by using the vertical circle tangent screw. Read both the verniers as it was read on the horizontal plate. So, the mean of the 2 vernier readings gives the value of the required angle. So, please see on the vertical circle, the graduations are 0, 90, 0 and 90. They are not marked as 0 and 180 degree. So, please note that on the vertical circle, graduations are just like 0, 90, 0, 90. So, change the face of the instrument, first reading with the face left and second reading with the face right, and repeat the process. The mean of the two vernier readings gives the second value of the required angle. The average of two values of the angles thus obtained is required value of angle free from instrumental error. So, in this way we can measure the vertical angle. So, for measuring vertical angle, sight A as before, take the mean of the two vernier readings and vertical circle, let it be alpha. Similarly, sight B and take the mean of the two vertical readings and the vertical circle, let it be beta. The sum or the difference depending upon the case of the situation, these readings will give the value of the vertical circle between A and B according as one of the points is above or below the horizontal plane, or both points are on the same side of the horizontal plane. Either they can be on the upside or can be on the downside. So, what is the more advantage of using the theodolite? We can also measure the magnetic bearing of a line. You must be remembering what is the magnetic bearing of a line. It is the horizontal angle which a line makes with the magnetic north. So, just to measure magnetic bearing of a line, we can use the theodolite also. So, how we can measure the magnetic bearing of a theodolite? Suppose we are to measure the magnetic bearing of a line AB with the help of a theodolite. How we can measure it? This is the procedure. First, set up the instrument over A and level it accurately. That is, we have to set the instrument at A, then set the vernier to the 0 of the horizontal circle, release the magnetic needle and loosen the lower clamp. That is, for left hand object we generally use the lower plate and its clamp screw, and for right hand side objects we use upper plate and its clamp screw. So, this is the important rule. So, now rotate the instrument till the magnetic needle points towards the north. Now, clamp the lower clamp with the help of a lower tangent screw. Bring the needle exactly against the mark in order to bring it in magnetic meridian. At this stage, the line of sight will also be in magnetic meridian. So, it is being shown on your monitor screen. So, now loose the upper clamp and point the telescope towards B, that is line AB. With the help of upper tangent screw, bisect B accurately and read both the verniers. The mean of the two readings will be recorded as a magnetic bearing of a line AB. Change the face of the instrument, and in the same way we can take the readings also. So, this is the last thing we can do, though we can use the instrument for a number of things. So, in this lecture, how we can use the theodolite for prolonging a straight line. That is how we can, as it is ranging is done with the eye, we can do the ranging with the theodolite also. So, there are two methods of prolonging a given line, such as foresight method and another is backsight method. So, in the foresight method, as it is being shown on your monitor screen, please see the sketch. Set up the theodolite at A and level it accurately. Bisect the point B correctly. Establish a point C in the line beyond B approximately by looking over the top of the telescope and accurately by sighting through the telescope. Shift the instrument to B, take the foresight C and establish a point D in line beyond C. Repeat the process until the point Z is reached, and in this way we can prolong the line AB to a point Z. So, in this way similar is the method backsight method as it is shown on your monitor screen. Set up the instrument at B and level it accurately as it is being shown on your monitor screen. Take a backsight on A. When the instrument is set up at B, take a backsight on A. Tighten the upper and lower clamps. Transit the telescope and establish a point C in the line beyond B. Shift the theodolite to C as it was set up at B. Backsight on B and transit or plunge the telescope and establish a point D in the line beyond C. Repeat the process until the last point Z is established. So, these are the two methods, foresight method and backside method for prolonging a straight line or producing a straight line or ranging a straight line as is done with the help of a eye. So, backside method as shown in the figure shown below. Now, if the instrument is in adjustment, the points A, B, C, D will be in one line, that is if the instrument is in the permanent adjustment. So, all these points will be in the straight line, which is straight line, but if the instrument is not in the permanent adjustment, that is line of collimation is not perpendicular to the horizontal axis, etc., then C, D and Z they will not be in a straight line. So, what will be the procedure? In that case, we can do the double reversing method. So, as it is being shown on your meter screen, this is the method or this is the solution when the instrument is not in the perfect permanent condition. So, when the line is to be produced with high precision or the work is to be done with great accuracy, then instrument is in imperfect adjustment, that is instrument is not in the permanent adjustment. In these two cases where a greater accuracy is required or instrument is in not perfect adjustment, then we use double sighting or double reversing method as it is being shown on your meter screen. A and B are 2 points which are to be produced to Z. We take 2 reading and plot 2 points C1 and C2, and with a greater accuracy point C is obtained between the center of the two. Similarly, when the instrument is set up at D, we point out 2 readings, one at D1 and one at D2, and the center of these 2 readings is D. So, in this way the same procedure is revised and we can forward or prolong this line AB to point Z effectively and very accurately. So, this method is used where high precision or accuracy is required and also the instrument is in not permanent adjustment or it is in imperfect adjustment. So, what is the procedure? Set up the threadlight at B and level it accurately with the face of the instrument left, back sight on A, and clamp both the upper and lower motions. Transit the telescope and set point C1 and C2. Similarly, loosen the upper clamp and revolve the telescope in the horizontal plane. Back sight on A, bisect A exactly by using the lower clamp screw and its tension screw. Now, the face of the instrument is right. Transit the telescope and establish a point C2 in line beside the point C2. The exact position will be C, midway between C1 and C2. So, measure C1 and C2, establish a point C exactly midway between C1 and C2, and in this way we can produce the AB to C. Shift the instrument to C and the same procedure is repeated and we can find out the point D and continue to the point Z. In this way we can move or prolong this line AB to a point Z. So, these are 3 methods. First is foresight method, next is backside method, and the solution of doing the accurate work when the instrument is not in the perfect condition or the work is to be done very accurately, then we use double reversing method which is being shown on your monitor screen. So, now we will solve some questions for home assignment. So, number 1 is enumerate the temporary and permanent adjustment of a threadlight. We have just studied what is the temporary adjustment which is done every time before taking reading, and permanent adjustment which is the relation between the fundamental lines of the threadlight. Second question is what are various methods used in measuring horizontal angle: ordinary method, repetition method and reiteration method. There are 5 definitions: swinging, plunging, changing phase, face left and face right, and draw a neat sketch of threadlight. What are fundamental lines of a threadlight? Okay. I hope you must have been benefited from my today's lecture. Thank you once again.